finished? Too easy? Okay, guys, you should be nearly finished those. Yeah? We'll have a look at the next topic now, which is also easy. Can we look up? So, what we're going to have a look at next is area of a triangle, and there are two formulas we can use. So, firstly, there's the baby formula, which you learn about in elementary school. Yeah. So the baby formula is the area is half the base by the height. And there's the height. And there's the base then. So that, like I said, is the formula for babies. So if this is 10 and this height is 5, then what's the area here? 25. Easy peasy. Elementary school, right? I'm sure you did this one in elementary school. The next one now is a little bit more advanced. So suppose we have this situation. We have our triangle. We know this side. We know this side. And we know this angle. And we want the area. So let me give you the proof. It's quite short of the formula. What you do is you draw a perpendicular line here and call that H. Yeah. Well, what does sine C equal? H over A. So H would equal A sine C. Now, according to our baby formula, the area is half the base by the height. And we have a formula for the height. It's A sine C. So, cleaning this up, we can get this formula. Area is a half AB sine C. That's our second formula. Okay, so we have just two formulas for this lesson. Let's have a look at some examples. You got that? Your t-shirt reminded me, when is the new Rick and Morty out? November soon, isn't it? Yeah. Nice. You know Rick and Morty, don't you? Yeah. What's with the face? You know Rick and Morty, don't you? Oh my goodness. Look at the student who is so uncool. You all know Rick and Morty, don't you? Yeah, okay, all right. Oh, you're missing out. You're missing out. Right, let's have a look at some examples now. So we'll start off with an easy peasy baby one. Base is 5 and height is 9, so you might need the calculator here. What's the area? Area would be a half times 5 times 9. What's that, please? 22.5? Okay. Now let's make this one a little bit harder. Next example. Okay. So let's say this side is 60, and let's say this side is 80, and let's say this angle here is 32 degrees. What is the area for this triangle? It would equal what? A half times 60 times 80 times sine 32. Right, so what's that then? 127. If we make these centimeters, then this would be 127 centimeters squared, yeah? Oh, 1,271. Well, three significant figures, so 0 then, yeah? It's okay. That one's straightforward. Okay, let's go on to the harder ones now. Can I scroll down? Yeah. Now don't worry, it's not going to be a crazy one. And this side is 2 meters. And I want the area in here. Now I'll give you a little hint. Okay, the hint is it's best to think of this as 6 identical triangles. So as soon as you get one area, you just multiply by 6 and you're finished. Okay, we got answers? 10.8. Let's have a look. So the area will be 6 times the area for one of these triangles. Now, you might remember that each of these triangles is equilateral. So that's 2, and that's 2. And what's this angle here? 60. So it's a half times 2 times 2 times sine 60. Yeah, so cancel. 12 sine 60, what's that? 10.4 meters squared then, yeah? Okay, let's go down and have a look at another one now. Can I scroll down? Yeah. So, find the area of a triangle with sides 10 centimeters, 10 centimeters, and 16 centimeters. Okay, so obviously you want to roughly draw this before you start. See if you can do this. I want the area of this triangle. You know how to check? Figure out it? What was the trick, or what was the key?
Half perimeter.
Half perimeter? Well, it depends what you mean by half perimeter.
I mean, you can solve it by half perimeter for more like.
It does involve half in it. That is one way to do it, yes. What did you do?
So to measure age, we divided our base from 16 to 8 and 8.
Good, yep, that's it. Yeah. So you put the 16 as the base, which was an important first step. The best thing to do is to write the 16 on the base, yeah. So, what's this triangle called this type? Isosceles. Now, that angle's the same as that. That's 10, that's a 10, and then you split that down the middle and make it 8 and 8. Now you have two right angle triangles, you can use Pythagoras. 6, and then the area is a half 8 times 6, isn't it? Oh, sorry, and then times 2 because there's no. Oh, sorry. A half 16 times 6, which is 48. Yeah. And you have, using this formula. Yeah, that's fine. That one's not on the course though, but if you know it, you can use it. Yeah. Okay. Can I scroll down? Yeah? Right. Yeah, okay. One more. Right angle triangle, base is 3, area is 6. Okay? Another right angle triangle, area is 30. Equilateral triangle, give me the area. Okay.
So 30, this is the side, or this is an area?
Area 30, area 6.
The height is actually.
Hmm?
The height is actually.
Which height?
This one.
The first, second, or third?
First.
Yeah? It's a right angle straight up. Yeah. Yeah? seems roughly right. So, first things first, we'll get this height here. And we can say a half the base by the height, that should equal 6. So what does that give us as the height? 4, is it? 4. So this side is 4, and then Pythagoras tells us that this side here is 5, and then we can get this height, which I'll call capital H, by the same process. A half the base by the height should equal 30. So 12, is it? You see what I was doing here. So this is 12. So from Pythagoras, what's this side? 13. And this side? And this angle? 60. So the area at the end is a half times 13 times 13 times sine 60, which is 169 over 2 sine 60, and what's that? Root 3 over 2, so it's 169 root 3 over 4. Which you can put as a decimal if you like. What is it? 73 point. So 2 then. Yeah? Okay, let's get you started on these. 1A, 2A, 3A, 4A, 5, 6, 7, 8, 9, 10, 11, 12. Well, not 12, I did 12. Okay, get started on those.